Subtract and write the resulting polynomial in descending order of degree. We have 12y to the fifth plus 5y to the third minus 7y minus 3 minus a 6y to the fifth plus y squared minus 7y plus 1. We'll start by writing an equivalent addition sentence. And remember that changes the signs. Now we'll collect our like terms, writing it in descending order. Now combine like terms. 12 minus 6 gives me a 6y to the fifth plus 5y to the third minus y squared. Minus 7 plus 7 gives me a 0y, and minus 3 minus 1 gives me a negative 4. So our answer is 6y to the fifth plus 5y to the third minus y squared minus 4. Multiply negative 4u to the fifth times negative 5u to the second. We'll multiply the coefficients and add the exponents. Negative 4 times negative 5 is positive 20. U to the 5 plus 2 is 7. So 20u to the 7th is our answer. Simplify negative 2a to the third all to the fifth power. We can rewrite that as negative 2 to the fifth times a to the 3 times 5 power. That gives me a negative 32 a to the 15th. We're going to multiply negative 2t times t to the third minus 3t minus 7. We'll start by multiplying each term inside our parentheses by the negative 2t on the outside. Remember, multiply means to add the exponents. Multiply the coefficients. That gives me a negative 2 t to the fourth plus 6 t to the second plus 14 t. We're going to multiply x minus 6 times x plus 6. These are conjugates, and so they'll multiply to give me x squared minus 36. Multiply negative 2a squared times a plus 1 times 2a minus 1. We'll start by multiplying inside of our brackets. So we'll have negative 2a squared times a times 2a plus a times negative 1 plus 1 times 2a plus 1 times negative 1. Multiplying, we get 2a squared minus a plus 2a minus 1. Combining like terms, we get 2a squared plus a minus 1. Now we'll distribute the negative 2a squared, and that gives me negative 2a squared times 2a squared minus 2a squared times a minus 2a squared times negative 1. Multiply the coefficients and add the exponents. Gives me negative 4a to the fourth, negative 2a to the third, and positive 2a squared, for a final answer of negative 4a to the fourth minus 2a to the third plus 2a squared. What is the conjugate of 6x minus 5? It's going to have the opposite sign, so the conjugate would be 6x plus 5. Determine if 91 is prime, composite, or neither. It's composite. And it's composite because it can break down into the factors of 7 times 13. Find the GCF. We have 180 and 396. First, we'll break down 180 into its prime factorization. That will break down to 2 times 90, 2 being a prime factor. 90 is 2 times 45. 45 is 3 times 15. And 15 is 3 times 5. So the prime factorization of 180 is 2 to the second power times 3 to the second power times 5. And we'll come back to that in a minute. Let's move to 396 and find its prime factorization. That starts by saying 2 times 198. 198 will factor to 2 times 99. 99 factors to 3 times 33. And finally, 33 factors to 3 times 11, making its prime factorization 2 to the second power times 3 to the second power times 11. The GCF is 2 to the second power times 3 to the second power, 2 to the second power being 4, 3 to the second power being 9, and 4 times 9 is 36. So our GCF is 36. Find the GCF of 60h to the fifth and 48h to the seventh. We'll begin by finding the prime factorization of each. For 60h to the fifth, that will equal 2 to the second times 3 times 5 times h to the fifth. For 48h to the seventh, that'll equal 2 to the fourth times 3 times h to the seventh. Our GCF is the greatest number of common factors, which is 2 to the second times 3 times h to the fifth, or 4 times 3 times h to the fifth, which is 12h to the fifth. So our greatest common factor is 12h to the fifth. We're going to divide m to the sixth divided by m to the fourth. That means that we're going to subtract the exponents. So 6 minus 4 gives me m to the second. We're going to divide 16x to the fifth minus 18x to the third plus 22x squared by negative 2x. We'll start by writing each part of the numerator over the denominator. Then we'll remember that we divide our coefficients and we subtract our exponents. So we'll have 16 divided by negative 2, x to the 5 minus 1, minus 18 divided by negative 2, x to the 3 minus 1, plus 22 divided by negative 2, x to the 2 minus 1. This gives us a negative 8, x to the fourth, plus 9, x to the second, minus 11, x. Find the unknown factor. We have negative 8x to the fourth times an unknown factor equal to negative 40x to the seventh. We'll find that missing factor by dividing the negative 40x to the seventh by negative 8x to the fourth. You divide the coefficients and you subtract the exponents. Negative 40 divided by negative 8 is positive 5. X to the 7 minus 4 is 3. So our missing factor is 5x to the third. Factor 12x minus 20. Think of a number that divides evenly into 12 and 20, which is 4. So we'll have 4 times 12x minus 20 divided by 4. That equals 4 times 12x over 4 minus 20 over 4, separating our numerator over the denominator. Finally, doing the division, 12x divided by 4 is 3x, and 20 divided by 4 is 5. So our final factorization is 4 times 3x minus 5. Factor 10y to the fourth minus 18y to the third plus 14y squared. Think of a number that divides evenly into 10, 18, and 14, and the greatest common factor of y to the fourth, y to the third, and y squared. That would be 2y squared. Now, separate each part of the numerator over the denominator. And then divide your coefficients and subtract your exponents. 10 divided by 2 is 5. Y to the 4 minus 2 gives me y to the second. Minus 18 divided by 2 is 9. Y to the third and y to the second. 3 minus 2 is y. Plus 14 divided by 2 is 7. The y to the second and y to the second. 2 minus 2 gives me 0. So it divides itself out, giving me a final factorization of 2y to the second times 5y to the second minus 9y plus 7.